Hi everyone, this is Raju from Smart AI Technologies. Welcome back. Today we will discuss a concept called speaker identification using deep learning. In this part we will study what is meant by speaker identification and why we need to learn about it and how we are going to implement it using Python and deep learning. So our third part will be completely hands-on. So don't skip the video. First learn about each and every concept and we will implement it then. So let us start with the concept. First, what is speaker identification? Speaker identification is a technique by which you can classify particular person voice from available audio. Okay, that is classifying the particular voice, that is identify a particular voice and a person based on the deep learning model that you are going to train. In our case, normally based on some theory, mathematical way, if you classify that particular person out of that discussion, I think if you are using Zoom and Google Meet, you will be knowing if some person is speaking, that person will be highlighted with a red mark around him. So that is done because of the speaker identification which is applied there. So this is a concept and why we need it actually. First application is in a group discussions. When group discussions are going on, example like Zoom and Google Meet, you need to classify one person who is speaking. So what is the need of it actually? So when you are able to classify who is speaking, that which candidate is speaking, you can highlight him. Okay, in the next case, once you highlight the person who is speaking, the other people, maybe 100 people are there. Okay, those 100 people will not be sitting in same nature. One person will be sitting in very noisy, some will be very silent, some will be some different noise or like that. Even they are not speaking, but the noise is there. So if one person is speaking, so and 100 noises are coming, bit noise, then also there will be distraction in the communication. So what if I find like, okay, this person is speaking, I will make this person voice come clearly, and I will make other sources, maybe other 100 people voices to go silent, or I will apply some filters to them so that the little low frequency voice will be reduced from those sources. We can understand. Okay, this will make user very happy, because no one likes to be discussing noisy area, noisy conditions. So then how we are going to implement it? Now we are going to use Python and our TensorFlow to build a deep learning model to do it, and I will be showing from dataset to the result. So first I will show the result. Here you can see in the I am providing a one wave file. Okay, one wave file. Then I will be getting the prediction result. This is Jen Stoltenberg. So I am giving input from the same folder, Jen Stoltenberg. I will show the data set. This is a data set. It is having two folders. One is noise and another one is audio. In audio, we will be having so many like we have 5 classes, that is records from 5 people. One is Jen Stoltenberg, which I am providing to my model. So we have more than 1000, nearly 1500 audios for each person. So this is a detail about our data set, and when you can see there are 2 folders for noise as well, but these wave files are very big than the recorded files. These are the noise files. Okay, so we'll see how we'll process noise files and the audio files, and how we'll mix them up while training our deep learning model. Don't skip the video, so watch it carefully. We'll be building that now. So here in the first part, I am going to import all the required libraries one by one. That is TensorFlow, operating system, join is file. Is there any file? Like, okay, to check that we use is file. How OS is used to access any folders and files or any part of our operating system. So TensorFlow is used to build the models. TensorFlow models are work with multidimensional arrays. NumPy is also used to work with multidimensional arrays. Shuttle we are not using, but you can use this library Shuttle to move the folders, copy the folders like that. Okay, then Keras, which is also used to build the models, that is layers. We will access those layers from Keras itself. Path is used to check the path. and append the paths are like that. Okay, to do that we will use a library called path. Display and audio, this is used to display our voice. Okay, you will be seeing those things, and sub process is used to control the process or execution process. Whatever we are doing, that we call it the process. To control it, we use a library called sub process. Using it can terminate the processing or like that. Okay, there are so many options to do. Once we import all the basic libraries that we need, now we need to access our data sets. To do that, what is the path? What is the path? Actually, when it comes to our data set, our main path is 16,000 PCM speeches. Under it, there are two files. One is audio and one is noise. So to define that, what I am doing is, my main path is this data directory, and for audio file, my path is audio, noise file, noise. So I will append that. Okay, when I will append, you will see audio path will be sum of that is attaching 16,000 PCM speeches slash audio, that you can see here. In the noise file path, it will be attached with noise. So once I do that, I need to check what are the folders are there. So when I check, you can see here J. Stoltenberg, Margaret Thatcher, Nelson Mandela, Julia Gillard, Benjamin Netanyahu. Okay? These are 5 people data we have. And when it comes to noises, we have 2 files. One is other and one is background noise. So this we now saw, but we want to see, okay, how many files are there in each folder. One is audio folder. In audio folder, in each category there are 1500, 1500, 1501, 1500. It means data is very well balanced. It means the data in Jen Stoltenberg, Margaret Thatcher, Nelson Mandela, Julia Gillard, and Benjamin Netanyahu, there are 1500 voices recorded for each people. So then comes noise. In the noise, what is the data is there? Under one file there are 2 files, and another file there are 4. Actually these are very lengthy. We need to do something because it's very lengthy. You can see here, when you can see Benjamin, okay, this data is less than 2 seconds or like that. Okay, but when it comes to noise files are okay, they are less in number, but they are very lengthy. You can see from each voice we need to cut that noise into bit small voices. That we will do in next part. Okay, that in the code, next part nothing but in the next code. Okay, now I am going to plot that as in a graph, how many voices are recorded for each people. For voices it's balanced. Okay, for 5 people it's very well balanced. So then comes to noise, one is 4 and another is 2, but they are very lengthy. Okay, then we will set some hyperparameters. One among them is, what is the validation split you want? You can give it anything. Okay, here you are defining how much training data, how much testing data should be considered. For example, if you have 20,000 voices, among 20,000 voices for validation, that is for testing how many you want to take out, and for training how many you want to keep. You can give it any range. Okay, 80-20, that is validation can give 0.2 20%, 0.25 25%, 30%. The best suit is actually 80-20. You can give like that. Okay, but now I am trying 90-10, that is 90 for training and 10 for validation. Shuffle seed is there. Okay, this we will do to shuffle the data. In the end we will append all the voices one by one. So their first person voice will be first, next person voice will be next, like that they will be appendation. So when we will do appending, we need to shuffle them. Otherwise for validation it will take only the bottom voices of only one person. We don't want that. Our validation should be also be a mixed data. So then comes the sample rate. Our sample rate is 16,000. Scale 0.5, amplitude. And what is the batch size? During model training, what is the batch size? Actually I am going with 128. It means I am pushing 128 voices for training at once as a batch. You can give 64 or 32 if your system is weak in training. Okay, if your system is better, you can go further 256 or more. Okay, epoch 15, you can try more than 15. Yeah, I am going with 15 epochs. Here we are setting all the hyperparameters. Then what I am doing here, I am first creating an empty list, that is noise underscore path. Then I will access all the noise files. Here you can see, that is I'll first enter into noise path. Okay, after enter into noise path, I will take all the subdirectories and I will append them. Okay, I will append them to noise underscore path. So the plus equal to nothing but that's it. So a plus equal to 1 nothing but a plus 1 nothing but add appendation of a plus 1 is updated there each time. Okay, so noise underscore paths will be updated. That path will be completely like this: ECM spaces noise. In the other file, in the noise also there are two folders, no? In the other folder there is a file called exercise bike.cs, sorry, wave, like that, pink noise wave. Okay, the dishes noise wave, that is a dishes noise is there. Okay, once we got it, okay, we got all the noise file paths. Now what I am going to use, I am going to use a library called librosa. By using it we can do so much with the wave file. So first I am going to load the wave file, some wave file, okay, from noise I am doing. You can do it on any wave files. Okay, then I am going to check what is the shape. Okay, then what is the rate. Okay, so it's normally 22,050, but we need to convert it into 16,000, that we need. Okay, again we can plot that, we can plot the amplitude and frequency of that thing that we are doing using librosa display.wave show. Okay, it will show us the complete wave, okay, time and amplitude structure of that particular signal whichever we are studying. So next you can do the same thing for amplitude dv. Okay, STFT. So STFT, when you plot it for the noise, it will look exactly like this. So then you can display, I think above I mentioned where we will use hyperparameters display. Okay, here I will use hyperparameters display to display the voice. You can play it and you can check the voice. Now as you can see, our data is very huge when it comes to noises. Our noise recordings are very high, so we need to split according to our interest, that is 16,000 steps per. Okay, so now what I will do, I will read each one. For that I am writing a function. So in this function what I will do, first I will read whatever the wave files comes to me, that is path. Once I will get the sampling rate and also the samples, how many samples are there. Okay, so now what I will do is, if sampling rate is 16,000, that's fine. If sampling rate is not equal, if not equal to 16,000, that's fine. If it's equal to 16,000, then what I will do is, I will take its shape, that is the total samples divided by my interested sampling rate. If I do that, I will get total number of samples. Okay, then that bigger noise will be splitted, okay, sliced. Okay, we call that as a sample. So I will split that according to my sample rate. So when I do that, you can see in the result here, my sampling rate, original sampling rate, then the total shape was this. From that, if I divide it by 16,000, I will get 61 samples, 60 samples, 95, 16, 61, 61. Okay, these are the total number of samples. Because we had 6 noise files, okay, 6 noise.wave files. For 6 noise.wave files we are getting these many samples. That means now that each one noise file is split into 61 smaller noise files. So then that numpy arrays, okay, now it will be in the form of numpy arrays, so that I am displaying here. So then what these functions are doing, I will let you know. Okay, let me first we will see what are the class names are there. Once we go to that audio path, we will get all the class names. Okay, so I am printing that speaker, Jensberg, Margaret structure, okay, like this. These are all the class names, that is the audio files. Then what is labels and what is the audio path. Okay, how we will get all the audio paths here. For that, first I will do, then I will take a class names. Okay, these are all the class names, and then I will go to that directory path, audio path slash names, that is Jensberg or like this. I will go to each folder one by one, and I will take inner files of them, that is .waves, and I will append them. Once I will do that, my audio path will be having complete all audio file links, audio file paths. Okay, each wave file path will be appended to this audio path. What is label? Label is nothing but these speaker names will be appended together. Okay, that will come as a labels. Now again, then whatever the data we will get, what we will do to it? Okay, one second. Now what we will do here, actually why the shuffling is done? This shuffling we will do, as I mentioned before, we don't want particular person or voices should be taken as only testing, and these people, top 4 people will come as a only training. We don't want like that, so we'll mix those rows or those values of speaker voices. So once we do that, okay, this is shuffling. Okay, so once we do that, we're going to split the data for training and testing. For that, what we'll do, we'll take validation split, that is 10% of my audio path will be taken for training validation, okay, and remaining for training. My train label is also same, it will be number of value samples, till number of value samples, nothing but 90% of data will come here, minus is there. Okay, so 90% of reverse will go now, so 90% of data will go for training, 10% of data will go for validation. Then comes create data set. How we will create the data set? So here you can see paths and labels to train data. It is a function which you defined above. So this function, what we are feeding, actually train audio path. It means we are providing all the audio paths one by one and labels one by one. Taking this, what this train DS will do, we'll see it now. Path and labels to data set. This is a function we written about. So what it will do, once you feed audio and its label to it, okay, here you can see, once it gets audio and labels, what it will do, it will call from tensor to slices audio paths. Okay, whatever the audio path will come to it, it will convert them into tensor slices. Okay, and then okay, what here that data, whatever the slices come to it, okay, what I will do, I will push to another function here, path to audio, that is this, it will read my audio file one by one, it will decode that wave file. Okay, here nothing but if any audio file comes here, it will first convert them into tensor, then it will read that. Okay, it will read that file and it will decode that wave file again, then it will push to, again it will convert them labels also into tensor slices. Okay, it means in the end what you will get, you will get zipped file of audio and label. So to be simple, this function, what this function will do is, here one wave file is there. Okay, here its label is there. Wave file will be a voice recorded file. Okay, its label will be that author name or a speaker name. Okay, it will take them, it will convert them into tensors. Okay, that is arrays, multidimensional arrays, and it will take them and it will zip them. Okay, it's just like if you go to any mart, you will see one object with its tag, then only you will understand. Okay, this object is this brand and its price. In the same way, it will zip both that person voice tensor, tensor, that is array, and also its label array. So when you push this data to any model, that model should train from it, because it will be having both input and output with it. Okay. Yeah, then train DS, what it will be, train DS will be having all the wave files with their labels zipped together. Okay, shuffling will be done here. Okay, the data will be shuffled up and down. For validation also same, only with validation audio paths. Now what is special here is, we need to add this noise files also. Our main concern about the noise files is, we need to add that noise file to our audio data. Okay, so what happens, if you train any model with our noise file and voice file included, if a person is speaking in noisy condition also, we can identify that person. that will do for all the training and validation data. So once we are done with that, we are going to build a deep learning model. Okay, so in the end we'll be giving number of classes you need to mention according to we are given about like we have 5 classes with us, and again you can mention softmax layer. Okay, not activation layer, you can mention it as softmax or some other layers. Then whatever the layers you build till now, you can use build model and you can get the model out of that. You can call that build model and what the function. Okay, you are calling that and name it as a model. That model summary we are going to get. Now you can compile it using optimizers, losses and matrices, whatever the things you want during the training part to be displayed. So then comes model.save. After training, that model should be saved in your local sector, then only you can use it anywhere by just loading that trained model file, that is model.h file, instead of training it again and again. Okay, early stopping you can use or you cannot. If you are training for 100 epochs or 200 epochs, you can go with early stopping, so that whenever loss is not reducing more or accuracy is not increasing more, then you can stop it. I am just printing that model here. Again you can, I am just mentioning 1 year. Okay, already the epoch value is mentioned above. You can mention 15 or 20 or 100 epoch. Okay, now you need to fit that, that is you need to train that model. Whatever the model you compiled till now, built and compiled, you need to train that for 50 epochs, 20 epochs or whatever the epochs you can. Otherwise if you want to mention epochs here, you can mention it here 20, 10, 100, 200. Okay, once you do that till 15 epochs, I was getting around 98% of accuracy. Okay, here I was just trying again now to train it only for 1 epoch and show you live, but it's fine. Okay, if you train it for 15 epochs or 20 epochs, you'll get far better accurate results. So then you can predict it on any user wave files. Okay, here I am taking it from sample data. Okay, randomly you can give your own input here. So here you can see from test ds, that is test data, I am taking some random values, 5 or 6 values, and I am feeding it to my model, but you can give your own input. Okay, that you can see here. Yes, it's here. Okay, you need to run these 2 codes and this one, because this predict is defined here. Okay, that loading the model and pre-processing of the wave file during prediction is done in this function. This will be same. Okay, once you see it or once you analyze it clearly, you will understand. Okay, this pre-processing before prediction should be same as the pre-processing till we done before training. Okay, so that you can see here. Once you feed your path, whatever the wave files you have, okay, now the prediction will be done. Okay, just remember. Okay, this is what we feeded and we are getting good results. This was all about today's class. We will meet in next class with a good example. Don't forget to subscribe and like our channel for further help. Thank you very much.